Howdy, y'all. Alright, my name's Gabe. I will be talking to you guys today about techniques for modeling and rendering realistic oceans and rivers. Rendering water is the title. Alright, let's dive in. I am so sorry that I put you through that. Okay, ocean rendering. Kind of a cool topic. Oceans, water's a lot different from modeling other things. It's like a terrain, but you kind of want more detail, and it looks weird if the lighting's off and stuff like that. So it matters. You can always notice unrealistic water in video games. Something I noticed immediately. So I thought it would be interesting to talk about. There's three major components. There's the shape of the surface, which is basically like how your mesh vertices kind of move like a wave. So like you have the mesh, which is the geometry of the shape, and that has its own issues, but how do you make it look like it's actually moving like water and waves and whatnot? And then there's some cool different shading stuff that you have to do with oceans as well as rivers, but those are basically the three things. So the first thing is the shape of the surface, which is, like I said, kind of how it moves up and down, like what the wave particles look like. So there's two ways of doing it usually. There's wave particles, and then there's the fast Fourier transform. Fourier transform. I'm only going to be discussing about the wave particles, but the Fourier, you can also determine what the vertices values should be. So I found a cool technique. It was basically you use grids of varying size and add them together to kind of generate the look of the ocean. So this bigger one, the bigger one, you can model like huge kind of swelling waves, and then you keep going smaller into like the finer details, right? So this will also feed into what I'm going to talk about next, but it makes it look pretty realistic because you can have these huge kind of swelling waves as well as like the smaller kind of stuff that's happening to the ocean as well, and makes it look a lot more natural when you have all that combined together. This is just how the wave particles kind of work. So they're basically like vertices, they're values, right? And you model them using this equation. You model x and y based off of this equation, right? So this b value is actually the roundedness or sharpness of this peak, right? So you can imagine like having, it goes from 0 to 1, and I think it's user set. So you can imagine, maybe having these be a lot more rounded. You wouldn't want necessarily to have this be a sharp peak, and then maybe have like those that have the b value be 1 or closer to 1. So it's a little more sharp and detailed, and you get those little crests, right? Okay, so generating the mesh. The mesh is basically the huge model that you're going to be using, right? And you don't want to have like the same level of detail across the board. That would be insane because you want as much detail as possible in order for it to look nice. But the farther and farther you get, you don't need that. So a way to skimp out on it is a structure that I found called clip maps. It basically has, these finer and coarser levels, right? This is the topology. And it's pretty cool because it moves with the camera, but it does so in a way, so it's not like we don't have anything like it, but it's not like following the camera necessarily, right? It calculates where the camera is, but it does these cool transition calculations so that it actually looks smooth when you're doing it. Because if you were to just move it like with the whole plane, you could tell it's like a whole plane. So it does this. Yeah, I got this little clip, and you can see like on these edges, some of these green ones, right, are smaller, and some of these yellow ones, or maybe not the yellow ones are bigger, but these blue ones smaller. So kind of moves with it and makes it look seamless, and is a good way to save on computation. Makes it so that you can have pretty fine detail on an ocean, computationally reasonable. Um, Here's a shader issue that I found. Well, a shader technique to stop an issue. So when you're modeling, I guess, any kind of a type of liquid that's translucent, but especially waves, you can see this. It won't get the correct light refraction and scattering as if it were like a mountain, right, where it's hard, because it has different diffuse stuff on the backside of it too. So what you have to do is a technique called depth peeling. So basically, what you do, you make multiple passes. You get the depth of the front of the wave, and then you render the subsequent layers. So like once you get this front one, you need to find the back ones, right? You keep going in, you find the back ones, and you render those first so that you can accumulate all this like light scattering and absorption that happens before you render this frontmost one. Because with the addition of it, it actually makes it look correct, right? Like, so you can see that, it's darker here, but you can see the, other crest of the wave here too. So this is just a technique to make sure that the ocean doesn't look like a plastic, singular, non-translucent kind of object. All right, let's move on to The River. Great album by Bruce Springsteen. Recommend it. So there's 3 steps, pretty much the same stuff as the ocean, very similar. One of the main things though is that rivers have a lot more kind of local stuff going on. There's like objects that need to be displacing stuff, and like there's more direction and movement. So I'm gonna start going through flow maps. These could also be used in an ocean. I think they are, but I think they're more important for rivers, so put them here. Obviously river has direction. So flow map is essentially a texture representation of a velocity field. So you can see down here, this is like a UV kind of map, 0 to 1. And then within this will be different colorings denoting the different directions, right? So you use that output to figure out the direction in which you want your vertices to go, right? So there's a lot of software that you can use to create these flow maps that I assume artists will be using to do that. Houdini is one, and you can output these maps as well as the normals for those maps. So, could easily be used in conjunction with our system. Maybe I had to make a new converter, who knows? Maybe a new data type. But yeah, that's what the flow map is. But there's some issues with flow maps. So sometimes when you create a riverbed or a little ocean bed thing with these flow maps, you get this pulsating kind of pattern that happens. It's pretty disturbing. Makes it look pretty unrealistic. Now this can be solved just by adding simple noise texture to the flow map. In addition, this also could be said for oceans too. When you're copying and pasting, this tiles to generate more and more of them, it starts to look kind of repetitive. And especially with like an ocean, I feel like it's, or a river, I feel like it's especially apparent. So in order to kind of combat this, what you can do is to add another layer of normals, and then you just take that layer and you shift it over to make it seem more natural. It's a quick, easy kind of, not hack, but little tip, I guess. Surface geometry of the river, pretty much the same kind of mentality as the ocean. You know, you want to use different levels of detail depending on the camera position, but probably on a smaller scale. So, you know, pretty much the same as the ocean, I guess. I don't know what more I gotta say. And here's the last guy. Adding surface objects is could be used in oceans as well, but it's an interesting issue and definitely something that you would want to think about when modeling and making a game. So in order to do it well, you should first represent objects on the surface as larger boxes, because you don't need that level, those small tiny little details in order to calculate what's going to happen to the water. You just need like this big kind of bounding volume, box or pill or whatever. And then using math, you can calculate, what the offset of this water should be, right? So if the surface level is, right where this purple is, and this object weighs so much, you want to push it down on the vertices that are under the object, and then the ones on these like sides, you want to push those vertices up. So that's how you kind of calculate the displacement of the vectors for your riverbed or ocean bed. And that looks like about time. So that's all I got. Thank you. And Fiend. Gotta end on a pun,